Yeah, audio good. Okay. Welcome back, everyone. Thanks for sticking around after the soup. Hopefully everyone enjoyed the soup. At least we did. And I think it's much better than the pizza from last time. So the most difficult slot, the after dinner slot. Yeah. But I came across your thesis, and I thought it was really interesting. So that's why we invited you. So please give a round of applause for Juha.
Yeah, hi. So I'm Juha Viljanen, and I will talk to you about measuring software maintainability. I did a thesis about the topic. I finished it last August. So I will present you the thesis results, and then I'll also be talking about what has been happening after that. So in the 6-ish months after that. So just something about myself. So what I do, I'm a software developer and a Scrum Master at a company called Napa here in Helsinki. We do software for the maritime industry. So for example, software that you can use to design ships with. For me, the most interesting things at the moment are clean and maintainable code. This is something I try to do myself as well. I'm still practicing, but it's very interesting to me. Then also lean startup is something really cool. And something nice that I had the chance to start working at now at work is user-centered software development, which I also think is really cool. So involving the end users more in the actual development project. Really good stuff. But hey, software maintainability. A really nice metaphor that I like to use in this is basically comparing working with a code base with transporting yourself in some terrain. So if you're working with a code base which is maintainability is really poor, it has a lot of technical depth, and it takes huge amounts of time to move forward there. I mean, if you think you're in the jungle, first of all, you're not driving a car, you're walking there, and you go forward really slowly. It's kind of tedious. You need a machete to cut all the branches that are hindering you in your work. And yeah, compared to the optimal state, which I might think also is more of an utopia, is the optimal code base where everything is perfect and you're driving a nice Ferrari, you're going very fast, it's comfortable, and you can almost feel the breeze of wind in your hair while you're driving there. Has somebody actually worked with this kind of code base? So is it not a utopia? No? Okay. What about this one? Yeah, sure. Yeah, but I guess you'll have seen these kinds of projects, right? Yeah. We own quite a lot. Yeah. Create them. And actually how metrics fit in here is that they can be used as a tool to more systematically improve your code base and its maintainability. So it's kind of like the Sherlock Holmes quote that we had previously. So if you want to base your decisions on actual data, or I mean, if you don't do it, was it a capital mistake? But yeah, so what we can use metrics for is to make more informed decisions. It can give you feedback on your changes. So if you've been coding a nice new feature, the metrics change to some direction and you know how your changes were, I mean, regarding those metrics that you're using. It can show you the most problematic areas in the code base. And you can also see trends there. If you've been using a lot of efforts for refactoring, then you might see, or at least you should see, some decline in the numbers. And in some cases, it might also be useful in just selling your refactoring efforts to management. I mean, when you have those hard numbers, then that might be helpful instead of just using your gut feeling. The biggest risk actually in metrics projects is this one. So nobody will ever use them. We had at least 2, maybe 3 projects earlier in our company which ended up more or less like this. It's actually a pretty poor quality picture, but I guess you get the point. So we had a nice idea of some metrics that we want to follow, and then it ended up being a build somewhere that nobody ever looked at, and so it was actually a worthless thing. So I would say that the key challenges when you're starting a metrics project is, first of all, make sure that you're measuring the right things. So because if you don't, I mean, nobody will be from start interested in those, no matter how pretty you package it. And yeah, also you have to provide the data in a as useful way as possible, and really integrate it in the current way of working of the developers. Because if it's an extra step in their process, they're not going to do it. They're not going to use those. So this is what I wanted to do, or what I wanted to research in my thesis. And I wanted to do it especially for our company, and our company's most problematic code base, which is written in Fortran. I don't know if you've heard of it. I imagine it's kind of similar like COBOL. I've never developed COBOL code, but I think it's from the same era. Yeah, so I wanted to know specifically for our company and this specific code, how can we measure the maintainability of it in a useful way, so that people will use it, and so that we can improve it in a more systematic manner. And how I measured it actually, or yeah, the research method was then that I was doing some literal research, or how I was reading through scientific papers to know how the current state of the art is, not reinventing the wheel, and then also because we wanted to know specifically in our case how it should be, I was asking all of our Fortran developers. I was arranging workshops for them and asking them what makes basically their life miserable when they're working with Fortran. So why is it time consuming to fix a bug there, or why is it hard to add a new feature? And then they were giving me some really concrete things that are some technical small details that are making their life harder. And then the next question was whether we can measure that. And that was the research question 1, so what should we measure? And then how we should use it. We were having a brainstorming session together, and they were giving me different ideas on how they would like to see the data visualized, and where they would want to use it, and when, and to get some idea of that. And this is the results I got. So I also asked them to prioritize the results. On what to measure, I basically chose the top 3, which were considered the most problematic things. And then, yeah, also about how we should use them, I got some ideas. It wasn't as straightforward there as in the technical problems. And basically, just a few words, why these top 3 are bad. Global state means that, for example, you're using global variables. They create invisible dependencies in the code, and well, for example, it could be that you're debugging file A, which has a problem, and then it's using a global variable, which can be also set in file B, C, D, and E, and maybe 50 other files. And then the value of that global variable in this specific case is incorrect, and then you're trying to find out where the wrong value is being set. It gets really complex. You need all those 50 breakpoints, and then, yeah. It's also not thread safe, by the way. Then we have these, for historical reasons, we're using these in-house data structures in our code. Because, we started developing this product in the 80s, I think, before I was born even. And at the time, Fortran didn't really have any good enough data structures, so we made it ourselves, but we made a poor one. Maybe at the time it was good, but definitely nowadays it's no longer a good data structure. And that has led to some really complex design choices. It's basically just a one-dimensional array, and if you're trying to model anything there, it gets pretty complex. lot of index manipulation and stuff like that. Okay, and then just a really common thing that I guess everybody of us is constantly struggling with is bad naming. So we have variables which are called, for example, str. It's a variable that has a string value, and I guess we all know what str should do. Or the functions can have really poor names. So yeah, that's problematic when you try to understand what the code should do. Yeah, so basically then the results that I got from the thesis are like the prioritized list of what are the biggest problems that we should measure. Out of those, I made a small metrics script that is parsing the code base, the Fortran code base, and then it's counting the instances of each time we're using global state in a specific way. Or of I have some like really simple heuristics for how variables should be named, so it's recognizing bad variable names. And then the other part was the list of useful ways how we should deploy these metrics, how we should use them. And then I have two prototypes, or I made during the thesis research, I made 2 prototypes of how we could do that in a meaningful way. So basically the metric script looks something like this. So it's a really minimal implementation. I mean, I did the thesis for 6 months, and this was a small part of it. So it's basically producing text files which have lists of all the files in the code base, all the Fortran files in the code base, and then the individual problems that we have there, and some other stuff. And then it also has the total value. Let's not go too deep into that. About the deployment practices, basically when I was going through the literature, and then also what our own developers were saying, there were basically 2 different ways you can use metrics. So you can either use them in a reactive way or in a proactive way. So reactive means that the metrics will provide you feedback for all your code changes. So in our case, we're working with pull requests in our company. So every time you make a code, every time you're making a new feature or a bug fix, in the repository you're making a new feature branch, you make your changes there, and when you're ready, you do a pull request to get it merged to the master branch. So that's a pretty good place to give feedback about how the code has changed. And yeah, this is one like how it then looked like. So this is the pull request. We're using Atlassian Stash. It's kind of like GitHub. And then basically it has a new tab there. I put it to the 4th tab actually, which was a bad idea. It's kind of hidden there. It should be in the first one. But here you can see, I mean, the thing about pull requests is that somebody else has to approve them. So somebody else than the developer himself has to look at the code changes and then say whether they were good enough to be merged to master. And then in this case, this person, which I actually later heard is the Prime Minister of India, I just wanted to get a picture of an intelligent-looking guy, I mean, on a computer, but yeah. So the Prime Minister of India noticed in this case that there is 66 new equivalences, which is a bad Fortran practice in the code. And then what he can do is that he can decide to decline the pull request and say to the developer that, hey, you know, you could just maybe do a little bit of cleaner implementation and try again, refactor your code and then try to merge it again. And then there's the proactive way where you look at the metrics, you dig in there, and you try to find and fix the biggest problem that you have there. So this could be a scenario that, you know, you come to work in the morning, and then you look at the metrics, and then you're figuring out where you could get the biggest bang for the buck if you use this day for refactoring. Let's say you have a quality day. In once a sprint, you can use 1 day for quality work. Then this could be a use case for that. So for that to work, you have to somehow sort the results, right? So what I wanted to have is just, I was showing you the file list, so I just wanted to have it in such a way that when you look at the first file in the list, that would be like the most terrible part or the most urgent part that you need to fix to get the biggest bang for the buck for your efforts. So in the literature, there was many papers actually talking about change frequency and file activity, and that was pretty interesting to me. So I tried that. The idea is that if a file is being constantly modified, then it's probably more important to keep in better shape than a file that hasn't been modified for like 2 years. I mean, if a file hasn't been modified in 2 years, then it's not having a big effect on our work. We don't have to worry about it. If it's stable enough, then we can just leave it as it is. And then, of course, the amount of technical depth is the other thing that we want to use for prioritization. So when you come to work in the morning, you open this text file, and the top part of the text file is the files that are constantly being modified, and those are sorted by the technical depth that they have. I called it the maintainability index. It could as well be could be called the technical depth value or whatever. The bigger it is, the worse. And then the stable files are at the bottom, and they're also sorted by the maintainability index value. And why it's important is that, you know, we have 2 million lines of code, so almost 14,000 files, and around 50 developers are at least at times touching the Fortran code. So it's obvious that we can't fix the whole 14,000 files, you know, the mass of code. But if you look at how many of those files are being constantly modified, it was like around 300 to 400. So that's something that you can work with. Still about the thesis, so the things you can generalize are that you should include your personnel when you're starting a new metrics project. I mean, you have to ask your developers or any other person who's going to use the metrics, who you want to use the metrics, on what are the most interesting things for them to see, because those guys probably know what are the problems in the code. So yeah, you should use that knowledge. And then also about the process, as I was showing you the books that were in the shelf that nobody ever reads, in our case the builds that nobody looks at their results. To not end up there, you better ask your developers what they think would be a good place to incorporate those metrics, when they would want to see them and where. And also there's this thing about emotional investment. So if you have somebody that's giving you input for your project, they feel kind of like that they own the project as well. And then they are more likely to use the results, instead of if, you know, I just decide that this is the thing we're going to do, and then I hope that people will use it. Also, I think it also makes sense to not only listen to your guys, because there might be some good ideas as well outside of the house. For example, the file activity came from scientific papers, and it was received well in our company by the developers. Yeah. So this is where I ended up when the thesis was finished. But if, as I said, we're a company that does software for the maritime industry that you can use to design ships with, or you can have the software on board. So, you know, we don't want to use too much effort into building the perfect code metric system and the nicest looking visualizations for it, because there are companies whose core competence it is to do this. And there aren't so many for Fortran, which is problematic. That's actually the reason why I was also working on specifically this problem in the thesis. But I think the most common metrics tool that there is SonarQube. It's a Swiss company that's making it, and it works at least for Java and C# and Swift, JavaScript, I think. And we also have some C# code and Java code in our company, so we're using it already for that. But I mean, obviously, you know, it doesn't support Fortran. It actually does support COBOL, but not Fortran. I think it's related to the Swiss banks, which are running on COBOL systems. But anyway, yeah.
You haven't heard of Code Climate?
No, I haven't. Code Climate.
Code Climate, you said it does everything you want.
Right.
But I guess it doesn't have Fortran either, but it
Yeah.
has a plugin now to your own.
All right.
Well, you probably have it already. You just need to plug it in.
Yeah. Okay.
But it does all the graphics and the smells, and you can sort by.
Okay, I have to check it out. Yeah, absolutely. I was actually we're talking. They have a plugin architecture, so SonarCube also has it, and this is what we went forward after my thesis was done. So they have a nice API actually that you can use to develop the plugin to add new language support, and basically the idea is that you just give SonarCube your data. You give it the numbers. Obviously it doesn't understand Fortran, so you have to do all the parsing. And then you just give the numbers to SonarCube, and then it will give you the nice graphics for free. And then you wouldn't have to worry about that later on. So what we did is that in Romania, where we have our other development office, I went there for a while, and we started a new project there with some 3 brilliant interns. They have really good technology guys there. And these guys, these 3 guys, they started building this plugin to add Fortran support to SonarCube. And it's still ongoing until the mid of May. And what we've done at the moment is that we have, this is how actually this is a test project. I didn't want to show our code base results to you, sorry about that. But so it can show you the issues that you have in the code. So major, critical, blocker, minor. For example, here in major, we have issues like this. So I was talking to you about global state. Here we have avoid reading from global variables, which is in the line above, where we're actually also using 2 magic numbers, which is also a terrible practice that you shouldn't do. So we're saying that if some global variable which is being set in any of the 50 places that we can set it, or decided to set it, then +6, because, 6, then do something. And this is from our code base, I just modified it a bit, but, this kind of code actually does exist. If something +6. Yeah. It's probably, I didn't go deeper into that, why we were doing it, but I guess it's related to the in-house data structures and the index manipulation and all the magic related to that. What else do we have there? Go-to statements are also bad. You shouldn't do that. Okay, but anyway, it looks like this. So you can see the code, you can browse the code. It will show you the issues. It can also show you the complexity of the code, the cyclomatic complexity. And we don't have to worry about any of this. We just give the numbers and say which line of which file it was happening. Then just few words about file activity. We're not using it in this product, in the SonarCube Fortran plugin. I went to the SonarCube conference last September to Switzerland, and I was asking there the guys. I had just finished my thesis and I was enthusiastic about it and about the file activity and all the new stuff I learned about that. And I was asking, hey, do you also have a metric about file activity, because I've been reading that it's pretty good. And they said that no, they don't have it, because every time you make changes to a file, then that file is probably active at the moment. So what they're concentrating on is more that so they emphasize the reactive approach and evolutionary improvement, that slowly you will get better. I don't know if you've heard of the Boy Scout rule. Uncle Bob has been talking about it. So every time you touch a file, you should leave it in better shape than it was before. So basically this is what they're saying. And for all the new changes that you're doing, you should have really strict standards. And the existing code, it's just there. I mean, it will slowly evolve to a better code base for those files which you're actively modifying. So yeah, I actually really like this approach, and this is the way we're going at the moment also. And in SonarCube, this is done by the pull requests. they have a support for pull requests and for Atlassian Stash and GitHub. So we're starting to use that soon. And then they also recently published a new plugin for Visual Studio and IntelliJ, where you can, it's kind of like ReSharper or those other tools that you already, when you're developing, you can get feedback for the code that you're writing. So that would be the shortest feedback loop. So yeah, this is what we hope to get soon. Then yeah, if you want to contact me, here is my company email, my LinkedIn, and if you're interested in the thesis, you can read it. It's publicly available online.
Any questions to you? I have a question. How did you calculate the technical debt? You had like a number there, plus 130, because that's like a composite of like multiple variables or like multiple items.
So in SonarCube, they're giving the technical debt in the unit is time. So basically, it's kind of like a ballpark estimate of how long it would take to fix this problem. So for each issue, we have defined that, for example, fixing this bad variable name might take 30 minutes, and then we just add up the numbers. So that's how it's done in SonarCube. And in my thesis, I was just talking to people, and I tried to get like the compound metric, the maintainability index. It was basically summing the different problems of that file, and then I had some weights which I was using. Since global state, I mean, reading a global variable isn't as bad as writing to a global variable, then I should have a bigger weight for the writing part. So yeah, that's what I did.
And like the time could then also convert to money, so you could even have like a monetary amount to the technical debt you're
which you could show your manager, and yeah. I'm kind of skeptical about those, but